All right, ladies and gentlemen, this is an overview of Chapter 9. Chapter 9, I rightly call it stoichiometry, okay? And the idea about stoichiometry is that we look at this concept map, okay? Think of stoichiometry as like a recipe for cooking. If I want to make 3 apple pies at once, okay, how many eggs am I going to need? How many cups of flour am I going to need? How many apples I'm going to need, okay? Those are the things you need to know. How many of each ingredient do you need in order to figure out how you make your 3 apple pies. So that's why I call it recipe for cooking, which of course also involves chemistry. Now, going back to stoichiometry, the center thing of stoichiometry has to do with moles, okay? And a mole is a number. Okay, it's a very giant number. It's Avo's number, 6.022 times 10 to the 23rd of anything. And a lot of people get confused and they say, hey, if I got 5 moles of water, how many grams of water do I have? And then they start multiplying 5 moles of water times this. And it's like, no. A mole is like a dozen. If I say to you, hey, if I got 6 dozen pencils, how many grams of pencils do I have? Well, you're going to count, well, okay, how many pencils are there? Okay, we got 6 dozen. Okay, I'll count out 72 pencils and that's it. But in reality, we know that a mole of anything is going to have a mass. 1 mole of water has a mass. 1 mole of carbon dioxide has mass. 1 mole of protein has a mass to it. And that mass is in grams. And that's a pretty important idea, okay? That the mass is in grams. So let's do a thing here where we can say 1 mole of H2O is about 18 grams per mole. Well, wait a minute. So a mole of water has a mass. Yes, because 1 mole of anything has mass. And a mole, remember, it's a number. Okay, we don't sit there and say, oh, I want to measure out 5 times 6.022 times 10 to the 23rd. No, you say, oh, look, I want 5 moles of water. Okay, well, I got 1 mole of water, it's 18 grams per mole. Well, how in the world did we find that? Well, that's when we use our periodic chart. And we break it down. The periodic chart tells us how many grams there are in a mole of something. For hydrogen, it's 1.01, and the oxygen is 16. You got 2 hydrogens, you got the oxygen, you add them up, it's 18.02 grams per mole. So now, of course, the question is, how many grams are there in 1.5 moles of salt? Okay, or 2.5 moles of salt, NaCl equals how many grams of NaCl? Or moles of A to moles of B in a chemical reaction. That's when you got to check out my other videos. It is in the stoichiometry playlist, okay, to answer those specific questions. Because these, if you understand the videos in there, and believe me, my videos are not the only ones out there, but you have a stoichiometry playlist that you can check it out, and it's detailed. You just need to sit down, spend the time, and go over a few problems, which is what I do in the videos, okay? But now we got to move on. We've got to talk a bit about percent composition. This is another thing. Percent composition, if you think about it, if you look at a ring, for example, that's made of gold, well, it's not pure gold because gold falls apart. So it has to be joined with another metal, typically silver, and we get an alloy. Well, what's the percent of gold to the percent of silver in a gold ring? 14 karat is pretty much the standard. If you go to 22 karat, it's more yellow and more bendable. If you go down to 10 karat, you've got more silver in there compared to the gold. And the gold does not as yellow as the yellow gold here. Now, my ring is a different story. There's another thing. I'm not going to worry about it. So if we look at the percent composition of NaCl, what's the percent of Na by mass? Okay, what's the percent of Cl by mass? Well, we know that 1 mole is 58.45 grams of NaCl. How did I find that? Well, I go to the periodic chart, I get these numbers here from the chart, and I add them up. So if I want to find the percent of sodium, it's 22.99 divided by 58.45 times 100. Again, refer to my videos. I go through all that wonderful stuff about percent composition. And that's a fairly important thing. Okay? All right. Moving on. We need to talk about percent yield because in a chem lab, we're making something and we need to know how much are we getting and how much are we actually, how much we should be getting and how much we actually get. And that's where we get the percent yield. There's an actual yield and a theoretical yield. Okay, again, you can refer to my videos on that, but I'm only here to talk about concepts, the big idea. The actual yield is what you physically got. That's our actual yield. You went in the lab, and ooh, hey, and I'm going to go and weigh it on my balance. Ooh, I got 5 grams of gold in this from this reaction. That's my actual yield. That's what I physically measured out. Theoretical yield is, it's the perfect world. This is what you would get. So on paper, I could calculate it. See, theoretical yield, it's on paper. And it's if everything is perfect and there's rainbows and unicorns, and I should be getting 10 grams of gold according to my theoretical yield calculations, but I only actually got 5 grams of gold. That's not a very good percent yield. That's 50%, especially for something like gold. Yeah, that's not good. Okay? Again, check out the videos for that. We need to go on with our final thing here, talking about the limiting reactant. So our limiting reactant, what do we mean by that? In the real world, you're going to run out of something. If we're making things and it's different ingredients, chances are we're going to run out of something. Probably the most expensive ingredient possible on there. So, for example, let's say you were making Caesar salad dressing with real anchovies, for example. So you've got all these ingredients to make the Caesar salad dressing, not the creamy one, the oily one, okay? And the anchovies, well, they're not the cheapest things on the market. That's probably going to limit you on how many liters of Caesar salad dressing that you're going to get, given that you have a limited amount of anchovies because it's your most expensive. So in chemistry, we talk about the limiting reactant. What do we run out of first when we run through a chemical reaction like this? So 6 grams of O2, 6 grams of H2, how many grams of H2O are we getting? Well, at that point, that's when we look at the video. Okay, you can refer to my videos on calculating the limiting reactant. Okay, now this particular problem is not in the video that you would watch. It's another problem, but the thing is, it's showing you guys how to do it. How do you change this? Okay, where basically you change these to moles, figure out how many moles of water you're going to get based off of these two. Whichever one makes the smallest number of moles of water, that is your limiting reactant. That's it. Okay? Because that is what you're going to run out of first. Okay? All right. Let's take a quick overview here of the things that we have covered. Okay? So we started our chapter talking about stoichiometry. We talked about moles, that it's a number. We know that a mole of anything has mass to it, and we measure that in grams. And then we have a mole of water, and we figured out how many grams there are in a mole of water using our periodic chart. And then we looked at problems like how many grams there are in a mole of NaCl, how many moles, if you have 2.5 moles of NaCl, how many grams of it, if you have moles of A going to moles of B in a chemical reaction. All those are covered by my videos in the stoichiometry playlist. I can't emphasize it enough. We talked about percent composition. We talked about the idea of rings, okay? That different karat gold rings have different amounts of silver and gold in them. So there's a percentage composition there. I looked at an example of the percent composition of sodium chloride, good old table salt. Again, refer to the videos for percent composition. We looked at percent yield, the idea of actual yield versus theoretical. Actual, you physically measured it in the lab, you're 5 grams of gold. Theoretical, you only do it on paper, you're not doing it in the lab, and find out, oh, hey, I was supposed to get 10 grams of gold, but I only got 5 grams of gold, and that's not good, because that means I have a 50% yield. Ugh. Okay? So then we talked, our last thing, guys, we talked about the limiting reactant. If we run a reaction through, what reactant are we going to run out of first? Because that is going to produce the smallest number of moles of product. Just like if you're baking, if you're making the Caesar salad dressing and you run out of anchovies first, that limits you. If you are making hamburger sandwiches and the smallest amount of the ingredient you have are the burger patties, that's going to limit you on how many burgers you can make. Okay, I'm hoping that this overview will be helpful to you guys, and I wish you the best. Take care. God bless.